All right, welcome to physics. Today we're going to be continuing our practice around calculating force and really continuing on from what we did um, from last week with momentum. At the end of the lab on Monday and Tuesday, you were talking about how the objects continue to move even though you changed the direction of the unbalanced force. You changed the force in the opposite direction, and it continued to go the way it was going until it slowed down and then started going the other way. And so that was actually an example of momentum, and some of you were really able to touch on that. So, before we get started, I wanted to go over the learning target that we're really focusing on right now with these activities. And so it is identifies, expresses, and uses patterns and forces, motion, and momentum to mathematically predict amounts of force, motion, momentum, and related quantities. So, really, it's about calculating these quantities and then making sure you understand what those numbers are actually saying. So, I've included here a couple reminders. Okay, we've seen these equations before. Force equals mass times acceleration can be written like this as well. And if you were to rewrite that, you can solve for acceleration if you know the force and the mass. So force divided by mass. So then a little bit of an introduction to momentum. So momentum is the measurement of mass in motion. And so, really, what it's saying is how much mass is in how much motion. And so, the more mass going a certain speed has a certain amount of momentum. If it's less mass going the same speed, then it's going to have less momentum because it's really a combination of mass and momentum, or motion, sorry. The symbol for momentum is a little different. Because you can't just use m for momentum, since mass is usually represented by m. So for common equations, it is usually represented by a p. That being said, I'm going to try my best just to kind of write it out, so momentum. But if you see a p, then that should represent momentum. The unit of measurement in every situation we're going to use, but also what you should see most commonly is kilograms times meters per second. That is the actual unit. Okay, and what that is said is kilogram meter per second. And again, kilogram then is your mass, and your meter per second is your velocity, right? That represents the motion. Another little note. For a collision occurring between object 1 and object 2 in an isolated system. So you have two objects coming together. The total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. Okay, so that's kind of a law of momentum and a characteristic or a trait of momentum. Next, calculating momentum, and this is what we're going to practice with a bit in this activity. So technically it would be P equals mv, and what that's saying is momentum equals mass times velocity. So hopefully not too complicated, but you will have a kilogram mass, and then you will have a velocity, or you'll have to solve for velocity, which we should know how to do from quarter one. So directions, very simple. Use equations above to solve and discuss the forces present in the problems below. To get started, though, I have a couple questions about Newton's first law and kind of getting you to think about what we've already learned and how it ties into momentum. Many of us, I think, are familiar with the concept of momentum, but haven't necessarily thought about how it's related to what we've already learned. So, just a reminder, Newton's first law of motion states, this is something we've covered 3 or 4 times now since the beginning of the year. So I'm hoping some of these are starting to sound familiar. But I'll give you a hint. Uh, Newton's first law of motion, one, you can look up the answer if you really want. Two, you can find it in previous activities or your textbook, or it is discussing an object in motion and an object in rest and what they tend to do. So you want to select all that are true. Okay, so more than one of these is going to be true. For number 2, how does Newton's first law relate to momentum then? So I want you to read the statements, and based on the definition that we just kind of reminded ourselves up here, which one of these or 2 of them will be true. So more than one again. Select all that are true. Then I have a couple scenarios with some values and calculations. So scenario 1, and you'll see that I kind of repeat it just so you don't have to keep looking back up to the top to see the scenario. So each question you have the same scenario repeated. So scenario 1, hitting a baseball, right? You're picturing a guy with a baseball bat swinging, hitting a baseball. So a baseball has a mass of 0.145 kilograms. And that's true. So I've looked all these numbers up just for the record, and is thrown at an average of 40 meters per second. This is definitely for the major leagues. 40 meters per second is about 90 miles per hour. But after the baseball is struck by the bat, the ball is traveling 49 meters per second, and the amount of time the bat is in contact with the ball is only 0.007 seconds, which is, I put it in this way because I want you to use seconds when you're doing your calculations. That's important. But that really is 7 milliseconds. So 7 milliseconds the bat is in contact with the ball. So problem 1, calculate the acceleration of the baseball as a result of the bat. And remember, acceleration equals velocity divided by time. Okay? And this is really going to be your average velocity divided by time. So again, keep in mind, if you're doing that, the starting value is going to have a velocity of 0. Okay? And then it's going to be accelerating to the speed or the velocity at the end in this amount of time. Okay? So you have the values there to solve for acceleration. Problem 2, again, same scenario, just copied and pasted so you don't have to keep scrolling up to find the information. Problem 2, how much force did the bat apply to the baseball once it was struck? So now that you've calculated acceleration and you know the mass, you can calculate how much force was applied to that baseball. And problem 3, how much momentum does the baseball have after it has been hit by the bat? So this one, you actually don't need any of the calculations you did above. It is already in the scenario. You know the mass, you know the velocity after it was struck by the bat, and so you can then calculate how much momentum it has. And don't forget to use the proper units, which will always be kilogram meter per second. Okay, back to where I was. And now scenario 2. So different scenario. I did the same thing where I copied and pasted the information you need so you don't have to keep scrolling up. And I'm really doing my best to include the reminders for you. So this is all stuff that we've covered before, we've practiced before in quarter 1 and maybe in quarter 2 so far already. So do your best to remember back to this. But here we are. What is the average rate of acceleration for this lineman? So this is an NFL lineman trying to sack the quarterback. So a defensive lineman for the Green Bay Packers, it's true, I looked it up, okay, weighs 315 pounds, which means he has a mass of 143 kilograms. During the NFL testing, the defensive linemen have recorded running. They do it a 40-yard dash, but for us, we want meters. So I converted it to 36.5 meters in 4.7 seconds. It's very impressive. So 36.5 meters in 4.7 seconds, you can calculate then that velocity, right? And so in this scenario, I would recommend the rate of acceleration. Okay, you're solving for this. You have VF minus VI, which again is the average velocity, or the change of velocity, I should say. So VF would be this end distance divided by that time. Okay, and then your VI, your initial velocity, is going to be 0 meters per second. So you do want to get the total change in velocity, and your time again, 4.7 seconds. We did a lot of problems just like this in quarter one. Okay, so what is the average rate of acceleration? You're solving then for this number. Do your best to include the correct units. Scenario 2, problem 2. How much force is the lineman able to tackle the quarterback with? Again, you've just calculated the acceleration of that lineman. Very large dude with the mass, okay? I've given you the mass. So now can you calculate the force in which he will be hitting the quarterback, if he hits him, right? Problem 3. How much momentum does the lineman have if he runs at his top speed? So we can calculate the velocity. And again, that should be a meters per second. So you do have to divide this to get that velocity times the mass to get the momentum. Excuse me. Problem 4. I'm adding an extra kind of problem to this scenario. So now, let's say the Green Bay Packers are playing the Seattle Seahawks. So the quarterback is Russell Wilson. If you don't know Russell Wilson, he's a very talented quarterback. He's very fast. Is good at getting out of tackles and that kind of thing. But so I looked up his weight and his mass and his 40-yard dash time. So here we are. So if the opposing quarterback is Russell Wilson, he weighs 250 pounds and has a mass of 97.5 kilograms. Russell Wilson can run the 40-yard dash, 36.5 meters, in 4.5 seconds. So what is Russell Wilson's momentum at his top speed? So I'm not asking you to do the acceleration, all that stuff. We're just going to talk about his momentum when he's at top speed. Okay, and then that brings us to the final question. Okay, this is all the same information. I included the same information from Russell Wilson's in the last problem. So short answer. After determining the momentum of the lineman and quarterback in this scenario, who has the advantage in changing their direction while running, the lineman or the cornerback, and explain why? So for this problem, I'm asking you to compare the momentum of the quarterback to the momentum of the lineman. And then if you go back and look at these will really help you kind of determine the answer to question 10. Okay, so if you can select these properly, it'll help you talk about this situation. So again, I'm asking you to think about, what does momentum mean? Okay, and if an object has more or less momentum, what does that mean exactly? And so in this situation, okay, what does that mean in terms of their ability to change direction? Okay, so then explain why, if you can include your numbers from question nine, yeah, problem four, but question nine, and problem three from question eight. Okay, if you can compare those values, include them in your answer, and then explain which one will have the advantage, uh, that should demonstrate to me that you're really understanding how momentum, Newton's first law of motion, is all connected. Okay, look forward to seeing you in class and let me know if you have questions.